In this lesson, we'll be working with radicals and rational exponents. On the left, you see our base value x has a rational or fractional exponent of a over b. On the right-hand side, we see exactly the same value but written in a radical form. Depending on the type of mathematical operation we want to perform, sometimes one form is better and sometimes the other is. So in this lesson, we'll look at converting back and forth between each form. Let's begin by starting with a fractional exponent. In this case, you can see that the numerator remains as the exponent. The denominator becomes the index of the radical. If we want to reverse the operation, the exponent remains as the numerator and the index becomes the denominator of the exponent. Let's look at that one more time. So converting to a radical, the numerator remains as the exponent. The denominator becomes the index of the radical. And it can travel back again. The exponent remains the numerator, index becomes the denominator of the exponent. Let's look at some examples. Here we have 4 to the power of 1/2. If we use what we just learned, the index of the radical is 2, the exponent is 1. So normally we don't write the index of 2 on a root. If we see just the radical symbol, we take for granted that it's a square root, or to the index of 2. And of course, anything to the exponent of 1, we just don't write the 1. So what we really have is just the square root of 4, which we know to be 2. A little bit trickier one. 8 to the power of 2/3. So our index becomes 3, our exponent 2. So what we need now is the cube root of 8. We know that 2 times 2 times 2 is 8. So 2 is the cube root of 8. And we leave that squared for now. So the next step is to apply our exponent and square it. 2 squared is 4. And there is our answer. 9 to the power of 5 over 2. So 2 becomes the index of the radical. All to the power of 5. The square root of 9 is 3. And 3 to the power of 5 is 243. One more. 64 to the power of 4 over 3. 3 becomes our index. 4 stays as the exponent. The cube root of 64 is 4 because 4 times 4 times 4 is 64. All to the power of 4, and we get 256. Let's look at reversing some the other direction. In this case, we have the square root of 4 to the power of 3. Remember that our index is really 2, even if we don't normally write it. So when we turn that into a fraction, it becomes 4 to the power of 3 over 2. The next question becomes, why would we want to do this? So let's look at an example of where this would become beneficial. In this case, we have the 5th root of 3 to the power of 2 times the 5th root of 3 to the power of 3. If we convert these into rational exponents, we get 3 to the power of 2 over 5 times 3 to the power of 3 over 5. Remember, when we multiply bases, we add the exponents. So 2/5 plus 3/5 equals 5/5, which is just 3 to the power of 1 or 3. Let's look at one that's quite a bit more complex. If we were to try to solve this without converting to rational exponents, it would be very difficult. But when we convert it, we get 2 to the power of 2 over 5 times 2 to the power of 3 over 4. So we need to add the exponents, which means we need to have common denominators. So when we put them into common denominators, we have 2 to the power of 8 over 20 times 2 to the power of 15 over 20, which gives us 2 to the power of 23 over 20. We can separate those out, and we have 2 to the power of 20 over 20, which is just to the power of 1, times 2 to the power of 3 over 20. So fully simplified, it is 2 times 2 to the power of 3 over 20. Now you can try practicing these on your own.